This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Lab. So once again, back to our Java example series. So far, whatever we have seen till here, okay, that check whether a number can be expressed as sum of two prime number. Oh, sorry, here. Last time we remember that, okay, we created one simple calculator using switch case. Just a second, let me just close this Telegram thing. Unnecessary disturbances there. Okay, so now the next question is that Java program to check whether a number can be expressed as sum of two prime numbers. Okay, yeah. Um, okay, let's see how can we solve it. I'll show you what exactly it's saying. I simply say that, okay, check prime number, select the main method, click on finish. So what exactly it's saying that, okay, let's say if I'm passing a number, any number, let's say I'm passing a number as 34, right? So 34, it's saying that whether a number can be expressed as sum of two prime numbers. So this is the requirement. A number can be expressed as sum of two prime numbers. It means number can be anything, but there is no guarantee that, okay, this number is a prime number. 34 is not a prime number. It can be divisible by 17, it can be divisible by 34, it can be divisible by 2, and it can be divisible by 1 also. What these guys are asking that, okay, sum of two prime number. So let's see, if I write 3 plus 31, so these are the two prime numbers you can distribute. Let's see, same thing, 5 plus 29, then 6, 7, 8, 9, let's see, 11 plus 23, like this. And let's see, the last factor will be 17 plus 17. So these are the four pairs we can create. That is the question is all about, the sum of two prime number that we have to see that. Let's see, if I'm giving one example, 11 can be expressed as sum of two prime numbers. No, it cannot be. Okay, because you cannot divide this particular number into two with two prime numbers. I cannot do that. Okay, so likewise you have to do. So it's a little challenging. Let's see how can we solve this particular problem. And it's very common question with respect to prime number. So what I'm going to do that, okay, I'll first come out of the main method. I'll quickly create a method over here that how to check the prime number. So for checking the prime number that we have already seen earlier, so I quickly create a method that public void that my number check prime number. This is the method I'll be creating it over here, and I'll be passing a number over here that, okay, hey, you take this number and tell that, okay, this number is prime or not. It means return a boolean over here. So I say that, okay, instead of void, please return a boolean. Right now, I'll maintain one, first of all, a boolean variable or boolean flag over here, like, okay, this is the prime or not. So let's see, initially it's true, like this. And then simple, I'll start a for loop. I simple say int I equal to 2. Yes, I less than number divided by 2, and then I plus plus. Okay, and then I say that, okay, if this particular number, the remainder with 2 is equal to 0, it means this is prime is equal to false. That's not a prime number. And then you simply break the loop. And when you come out of the for loop, I simply say that, okay, return is prime. Okay, like this. Right, so I'll be calling this particular method. Let's see over here, I'll just call this method with the static so that we don't need to create the object of this class. Check prime number, and I'll pass it, okay, my prime number is 17. So let's see it's giving something or not. I simply say that system.out.println with 17 I'll be printing, and let's run it. So we are getting that, okay, yeah, true, means 17 is a prime number. If I'm passing, let's see, 34. Okay, so let's see, if 34, it's saying false, 34 is not a prime number. Fine, so my logic is perfectly working fine. Now, but that's not the thing that we have to do that. We have to do that, okay, we have to find out a number which can be expressed as sum of two prime numbers. That means I'm just passing any number over here, and then it should check that, okay, it should be sum of two prime numbers, like that. So we have to print something like this in this particular format, and then we have to figure it out, okay, 3 plus 31, 5 plus 29, something like this. So I'll do one thing, I'll maintain one number over here that we will pass this number to this guy, and let's see, I'll take this 34 only. And then I'll maintain one more boolean flag over here that flag initially is equal to, let's see, false, right? And then I'll start my loop over here that let's see, int I is equal to 2 and I less than equal to this number divided by 2 over here, and then I plus plus. Okay, and then I'll simple call this particular method that this method is giving you what, this condition that is a prime or not. So I'll simple put one if condition that okay, if this prime number, this number is a prime number or not. Okay, check prime number, and we have to pass the same number over here. Or let's see this number I'm just giving that I over here. Okay, instead of number, I'll be just giving this counter over here, whatever the 2 that I'm passing, because we have to figure it out. Okay, we are not bother about 34. Now we have to figure out all these guys, all these combinations we have to figure it out. So don't pass number over here, we have to pass the index I equal to 2, 3, 4, 5, 6 up to divide by 2 length we have to pass it. So after this, what I'm going to do that okay, I'll put one more condition over here and then call this particular method once again. Check prime number, and then we have to do whatever the number minus 1 also we have to pass, right? So 1 I'm passing starting from 2, and the second I'm checking from the okay, from the number minus 1. So let's see, 34 minus 1, 33, 34 minus 2, like this I'll be checking over there. And then in this particular if condition, I simply say that system.out.println, okay, or let's see system.out.println, what I'm going to do, I simply say whatever the number that you have. So this number, I'll do some formatting, is equal to with some space plus, and whatever the index I, then one space, then plus. Okay, I'll just print this plus over here, and what, that number minus 1. Okay, something like this I'll be printing. Number minus I will be printing with this message. I just need to do proper formatting. Okay, yeah, like this. And once this is done, I simply say that okay, your flag is equal to true if this condition is satisfied. And then what I'm going to do that I'll just come out of the for loop, and then I'll put a one condition over here that okay, if your flag is not true, it means if your flag is false, in that case it means you simply print a message that system.out.println that whatever the number that you're passing, which number, this number plus cannot be expressed as the sum of two numbers. I simply say that expressed as the sum of two numbers, like this. Now don't be confused, I'll repeat the logic again. Now see the logic, what exactly I have done. This question long time back. So this is the prime number method, check prime number method I have written. Now after that, what I'm going to do, after that I'm simple making this particular variable 34, making this flag equal to false, and then starting a for loop, and then calling this method check prime number I equal to 2. So it will check that okay, yeah, I equal to 2 is a prime or is not. Okay, well, let's see, I equal to 2 I'll be passing, and then I'm calling one more time this particular method with number minus 1. It means whatever the actual number that you have, 34, and then you simple do 34 minus 1, because I don't want to check with 34 because I just want to check with 34 minus 1, because if you take 34 already, then you cannot divide it into two expressions over there, right? You cannot write like 34 plus 0, because 34 is not a prime number in that case. So better you write 34 minus 1, it means number minus 1, to make it generic. If it is minus 1 and it's giving you true, then you simply say that okay, yeah, this number actually print the same number with that particular I factor. Okay, this particular I factor, because you have already checked that okay, this I is a prime number. Then you have to come inside this if condition. These are not two separate conditions. This is the outer condition and this is the inner condition. So first this condition should be satisfied, then only you have to check in the reverse sides. Otherwise you simply ignore that, and then you simply print in this particular format number is equal to I, whatever the I is going on, and then number minus 1 over here. It means we got our expression over there, we got our factors over there, and then you make this flag equal to true, right? Why flag equal to true? Because initially flag was false. That is what I'm saying, is flag equal to true. In that case, let's see, this entire thing is not getting satisfied. In that case, what will happen? You simple come over here. What is the flag equal to false? It will make this particular true. It means that we could not find the expression over here. So that's a simple print message that okay, this number cannot be expressed as the sum of two numbers, sum of two prime numbers. So let's see this logic is working fine or not. So I'm passing 34 and then let's see. 34, 2 plus 32, 3 plus 31. No, this is somewhere we have done some mistake. See this 4 plus 30, it's exactly giving all the factors, but not like that we were looking for. So let's see how can we fix this problem now. So see this number minus 1 or number minus I, actually that's my mistake, because I equal to 2 we have to divide this number with minus I, whatever the I is going on, not with the reverse thing. Okay, and now let's run it again. Now we have shrink the data. So 3 plus 31 we are getting 5 plus 29, 7 plus 27, but 27 is not the prime number, so again we are getting the wrong output. But 11 plus 23 is right, 17 plus 17 is right, but 15 is not a prime number. 15 can be divided by 3, 5, 1, and 15 itself, so that's also a wrong output. It means somewhere we are doing some mistake once again. Okay, so let me check what exactly the mistake we have done. I equal to 2, check the prime number I, number minus I, system dot out print this, and flag equal to true. If this, fine. And then in the logic itself, are we doing any mistake? Is prime equal to true, I equal to 2, less than number. We have forgot to write less than equal to. That's a problem. This equal to will, okay, make a problem. Now let's run it again. This equal to 0. Okay, now let's run it again. Okay, but again, we are getting the same output. Not an issue. We'll see what is the problem now. Is prime is equal to true, I equal to 2, less than this, and I'm doing so many mistakes today. See, we have to write I over here. I have just written 1 with 2 only, right? That's the problem. Perfect. Now this is the right output. Right, guys? So it looks easy, but when you write it, see, I did 3, 4 mistakes from my side. I'm really sorry about that. I was not at all prepared. So like this, we have to solve it, guys. So we have to keep checking. See, this is the mistake, silly mistake. I have done it over here. Instead of I, you have to write 2 over here. And then, guys, you have to deduct with number minus I, not with number minus 1. Okay, so 34 minus whatever the number is there, 34 minus 2, it means 32. It will check with 32 actually. Okay, so and the next time will be I equal to 3. It will check 3 is the prime number. Then again it will do 34 minus 3. So you will get 3 and 34 minus 3. So you will be getting 3 plus 31 over there. So we will get a first pair like that. And then within the loop, if you run it, you will be getting all the factors over there like this. So this is the right output. This is what we are expecting. Little complex, but we have to solve it. It's a very famous interview question over here. Okay, perfect. So now let's see, the next thing is Java program to find the sum of natural numbers using recursion. So this is done. Let me just, okay. Find the sum of natural numbers using recursions. Okay, like natural numbers, I think we have already done it right earlier. See, natural number sum, we have done it using simple for loop over here, or simple while loop also we have done it. Now, but using recursion, okay, fine. So I'll create one more class. I simply write it like this: natural number sum with recursion. Okay, so how to solve this? It's very, very simple. See, whenever we are talking about recursion means a method it's calling itself. That is called recursively programming. Okay, a method is calling itself. So obviously we have to create a method for that, and we have to write a logic, which will add the numbers. So I simple write, let's see, public static, and which will return integer, and then I simple say that add number. and which number, let's see, whatever the number that you are passing over here, right? Now, this is integer. Now, I simply say that, okay, if condition, if this number is not equal to 0, then only you have to do it, and you simply return that, okay, number plus same method you have to call, this same method you have to call recursively. Okay, add number, and then you pass the same number with -1. Okay, so we have to talk it like this. If I'm passing 10, 10 plus 9 plus 8 plus 7, like this, we have to do that. Okay, number -1. Else, what do? You come over here inside the else part, and then you simply say that, okay, you simply return number, the same number that you return. Okay, so then I'll be calling this particular method add number method, but first I have to declare a number. Let's see, number is equal to 20, and I call this method now add number and pass this number over here, which will return what? Will return one integer. So I'll store an integer over here. Let's see, integer sum is equal to this, and I simply say that sum of numbers we have to find out, right? I simply say that sum of sum is something like this plus sum. Okay, so let's run it and let's see. I think it will be fine. So we are getting sum of 20 is 210. What is sum of 5? Sum of 5 is 15. Why? Because you have to do it like this: 5 plus 4 plus 3 plus 2 plus 1. So 9 plus 3, 12 plus 2, 14 plus 1, 15. Same thing if you write 20, 20 plus 19 plus 18 plus 17, like that, up to 1. And natural number means, always remember, guys, what do you mean by natural numbers? Natural number means positive numbers are called natural numbers. 0 is not a natural number. It will start from 1, 2. Okay, it will start from 1. 0 is not the natural number. Okay, so this is recursively, I'm calling the same method inside this method. So I'm calling this method by recursively. So this is a simple problem. You might, okay, face this question at the time of interview. So let's close this and let's see what is the next question. So this is also solved. It's saying find a factorial of a number. Yeah, that's why I was thinking that, okay, why this question was not coming. Okay, factorial of a number using recursions. Factorial number, we have already seen that earlier, but using recursively is also very famous. This is very, very famous college time question, right? Okay, so factorial with recursively, factorial recursive. Select the main method, click on finish, and first what I'm going to do, if it is recursively, then I have to create a method first. So I'll be creating a method over here, and I simply create a method. Let's see, public static, which will return one integer, and I simply say that, okay, multiply numbers. Okay, and whatever the number that you are passing, whatever the method name you want to create, you can create that, and same integer number I'm passing. And then I simply say that if this number is greater than equal to 1, right, guys? If number is greater than equal to 1, then you return what? Then you return number which is multiplied by, call the same function recursively. You call this particular function and then you simply pass number -1. That's it. That's so simple. And then else part, you simply say otherwise you return 1. If you're passing 0, the factorial 0 will be 1 in that case, right? So let's see if I'm passing 5. So 5 is greater than 1. Yes. Number 5 multiplied by number -1. So recursively it will call number -1 means 4. 4 will be called and 4 will be given to this guy. And then again number multiplied by, okay, 3 in that case. So 5 plus 5 multiplied by 4 multiplied by 3, 2, 1. Like that, recursively it will do that. And once the number is reaching less than 1, then it will come out of the if condition and then it will return. So how will you call it? You simply call this particular function multiply by number and passing, let's see, 5 over here. And I simply do one thing, system.out.println, directly call this particular number. Call this particular method, passing the number 5. Perfect, 120, right? 5, 4, 3, 2, 1. If you do multiplication, you will be getting 120. So factorial 5 is 120. Let's see what is the factorial of 10. So factorial of 10 we are getting C. That's a huge number, right? What is the factorial of 2? Factorial of 2 will be what? 2 multiplied by 1. Right, simple. Factorial of 0. Factorial 0 is 1. See, yes, factorial 0 is 1. Simple. So recursively you have to solve it. So recursively, guys, that's very famous in binary tree also. We have seen that earlier. Okay, in data structure series. Recursively, you can just minimize the all the looping conditions and everything. It will be very simple. Okay, because in recursively also you have to start the loop and then you have to put a condition over there. Okay, that number or up to number divided by 2 or something. In that case, you have to start a loop. But here recursively, you just call the same method and keep decreasing the value over there, just like number -1 I have decreased, and then calling the same method within the method. That is called recursive, right? Okay, now let's see the next question. The next question is the GCD and FCB and all these things I'll do it later. So GCD part I'm just ignoring it. Now let's see, convert binary number to decimal and vice versa. So what I'm thinking is, guys, that all these questions, right? Binary, octal, binary, okay, these questions, 3 questions, I'll prepare a separate series for that because it's not that very straightforward, right? Because we have to do some, we have to understand what do you mean by binary number, what do you mean by octal number, what do you mean by hexadecimal number, and all those things. Okay, so that I'll show you in the next video. So I think for this particular video, I think these things are more than enough. And how many? I think I know very less things that we have prepared. Only 3 programs we have written. But yeah, please check and then let me know if you have any issues. But next time onward, we will take more and more. Okay, let's say around 7 to 8 at least we can cover in the single video. I was not having time, I'm running out of time. But in the next video, definitely I'll prepare around 7 to 8 because this conversion of the binary, octal, and all those things, it will take time to explain. Okay, because we have to do some calculation. You have to understand the calculation. Simple mathematics you have to perform, and the same thing you have to do it in the form of programming. Okay, so let's ignore this thing as of now, and then we will do it in the next video. Thank you so much, guys. Thanks for watching Naveen Automation Labs, and let me know if you have any issues. Thank you so much.